Now that we are supposed to understand the concept of function, graphing of a function, and so on. And now we're going to look at different types of functions. In this case, at the moment, I'm going to recap what you know from school and maybe just emphasize a bit if there's something to highlight. Let's just say maybe, I don't know whether it's with, let me just write functions instead of saying types of functions. Just say functions. Right. I think the simplest or easiest types of functions to manipulate are polynomials. Let's say polynomials. Polynomials. I'll start with a general polynomial which is given in this form. A0 plus x plus a1 x to the power 1 plus a2 x to the power 2. That will be a parabola, isn't it? When we're looking at it. Then plus dash 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 up to a n x to the power n. All together. Now, if it's like that and the a n is not equal to 0, let's say a n is not equal to 0, then we say this is a polynomial of degree n, isn't it? That's right. The degree of the polynomial is n. Or the order of, yeah, I think the degree of polynomial is n altogether. Now, if we then, let's suppose that all the a-n's from, let me say, let's say from here, all these a-n's are equal to 0. A-n's are equal to 0 for n greater or equals to 2. Then what we have here? We have our usual equation of a line, which you say a0 plus a1x, where a1 is what you usually call what? M, the gradient of the line, isn't it? Okay. Now, what is important about this thing? You must know the significance of a0, the significance of a1, and then you must be able to graph the function. Remember, yesterday we also discussed what piecewise defined functions. You cannot plot those functions if you don't know the elemental basic functions in their characteristics and so on. So now, if let's say a1 is greater than 0, we know. Then let's say suppose a0 is somewhere there. Then the line will be something like this. In other words, the line is growing as you move from the left to the right, isn't it? Now, but on the other hand, if a1 was less than 0, what would happen? Then the line will be a different line, which will cut exactly the same intercept, but will be going down there, isn't it? That's right. And everybody, I hope you understand that if you get 2 points on the line, and this is very important because the next in few weeks time when we start on the other chapter on differentiation, we'll basically talk about this thing again, which in this case what I want to highlight here. If you've got 2 points on the line, let's say you've got here x1, y1, and then somewhere there you've got x2, y2, then your m, which is in this case here equals to a1, is going to be equals to y2 minus y1 over x2 minus x1. We are going to need this thing a lot when we start our derivatives and so on. And once you've got that, I hope you see that this is a change from x2 to x1. In other words, this gives you a kind of a characteristic triangle for this line, which goes this way and it goes that way. Do you see that? So this x2, x1 is this distance there. This y2 minus 1 is that distance there. Altogether. Actually, if you notice that this is actually defining the tangent of this angle there, isn't it? Tan of that angle. Altogether. So that is very important there. Now, then I think I've explained what is A0 there. Then if we now change this situation, let's say we change this situation, now we allow an to be 0 from n greater or equal to 3. You can see that this is going to be what? A parabola, isn't it? So a line is a binomial, meaning it has got two terms. If we are talking in terms of polynomial, then if it's a constant, now as a1 is equal to 0, then we get a constant function which says y is equal to a0. Then we get that line. I'm saying here, let's say a1 is equal to 0. Then what are we going to get here? We're going to get y is equal to a0. What type of a line is that? What type of a line is that? Y is equal to a0. It's a line which is cutting through a0 and is horizontal. But I'm saying, what type of line is that? You don't talk. Now when I'm saying horizontal, you join the chorus. Okay, so all those things you must know very well. All together. Okay. Now, let me get rid of this. Let's go. Those are polynomials there. I'm not going to continue with the parabola. I think if there's something we need to discuss, is there anything you want me to clarify in the parabola? Okay. But I think there is. I think there is something I would like to clarify on the parabola. Let's just clear this. Now, let's come back to the parabola a bit. Let's take the standard parabola. Y equal to x squared. Y equals to x squared. Then I think you understand that when I'm looking at this parabola like this, the general equation of the parabola is a x squared plus b x plus c, isn't it? So when I'm here, I'm saying a is equals to 1, and I'm saying b is equals to c equals to 0. All together. Then that parabola would be something like this. All together. Then we need to understand now, if we've got y equals to a x squared, and the a is not equals to 1, we need to know what's going to happen. All together. So, first of all, if a is between 0 and the 1, what do you think is going to happen? Tell me. If a is between 0 and 1, what's going to happen? Sorry? Talk. You're right. I think you're right. The way I'm missing your questions, I think you're right. What do you say? Now, look what's happened there. Just take a number like 1, number like 2, and 3. And then minus 1, minus 2, minus 3. And let's say a was equals to half. What's going to happen? We're going to square 0. And after squaring 0, calculate this half. What is going to be? 0, isn't it? So let me take another color here. It's going to be 0, which means the graph is going to be there. Now when you get to 1, instead of coming there at 1, we're going to square 1, then calculate the half of 1. It's going to be half. Then the graph is going to be somewhere there. Altogether. Then if we go to 2, we're going to get 4. Instead of going to 4, we're going to be somewhere at 2. So that's going to happen exactly the same way because this is a symmetric graph. So you'll find the graph going more or less this way. What has happened to the graph? It has opened more, isn't it? Now, but on the other hand, if we take A to be 2, in this case A is greater than 1. If it's 1, it gives us the first parabola. If it's greater than 2, what's going to happen? Exactly at 1. It's going to be 1 squared. 1 times multiplied by 2. Then the graph is going to be now somewhere there. And this side there. And then when you draw that, then it's going to be narrower going up. Altogether. That's the thing. Then the other transformation, basically what I'm talking about here, we are transforming the variable of f. Now if I've got 2, instead of having, if I said this is f of x equals to x squared. Now when I've got here being 2, it's like I'm having f of 2. Sorry, I'm multiplying f by 2. In other words, I'm multiplying this function by 2. So something there. Look, I'm now having a new function whereby I'm now having x, but this function now is 2x, and what you can see, the growth becomes accelerated. But if I've got g of x, which is half of x squared, the growth goes a bit slower, the parabola widens. Altogether. Then we also have got what we call horizontal and the vertical shift. If I add, let's say I add 1 here. That is 1. Remember, this is y. So which means 1 is added where? In the y direction, isn't it? So which means the graph is going to be lifted up, and then we're going to see the graph coming, same graph but coming somewhere there. That's a vertical shift, isn't it? If I put -1, it's going to be pulled down. Then the next thing is what we call the horizontal shift. In the horizontal shift now, you will be manipulating the what? The variable itself there. Then it needs us to change this, to look at this equation again in another way, whereby, let's get rid of this. I think you know, using those techniques of completing a square, I hope you haven't forgotten completion of square. We can transform this equation to look like a brackets x minus h horizontal squared plus k for vertical. Altogether, what do I mean there? I mean this is a horizontal shift and this is a vertical shift, isn't it? So you must also understand what happens if there's this kind of a situation in the argument there. The graph will either move to the left or translated to the right. Then the k will either lift it up vertically or downward, isn't it? All those things are things you must understand. Altogether. Okay. Then the other function which maybe you didn't do at school, or you might have done it, so the problem which I need to highlight here is the absolute value function. But before I explain this idea, I think first of all we need to unpack the meaning of absolute value before I talk about what the absolute value function. Now, then let's say we've got a number line there. We've got 1, 2, 3, now there is something which is common for minus 2 and 2. Now, what I want to say here, what is common between minus 2 and 2? If I tell you that my point of departure is 0, there is something common between minus 1 and 2. What is it? Distance. The units. Let's say if you take 1 as a unit, this as a unit, this is the same thing there. It's 1 unit. This is 1 unit, the unit. Otherwise, 1 is 1 unit away from 0, and minus 1 is 1 unit away from 0. So what does it mean? It means that if I was to talk about the number of units between 0 and minus 2, and the number of units between 0 and 2, it will be the same. How many units will be there? Will be 2. In simple words, that's what we call the absolute value of 2. So if I can write, how do you write it down? We write it down as minus 2, this bar, and we read the absolute value of minus 2. Then this is the same thing as absolute value of 2, and that is 2. In other words, we can just say absolute value of a number is the number, ignore the sign. I mean, that's what appears to us. But now, to define the absolute value function, we need to roughly understand that, and even if we want to look at this graph, we need to write something like that. But it's simple. I think you must understand now that if I've got a number x, and I want its absolute value, and please note that absolute value is always a positive, a non-negative number. Now it is greater or equals to 0. Altogether. So now if you want to define absolute value of x, and you want it to be always greater or equal to 0, this is what we do. We will say the absolute value of x is the x if x is greater or equals to 0. But x is not always greater or equal to 0. It could be less than 0. Is it? Then, if you've got a number which is less than 0, you want to produce a positive number from it. What did you do? You've got a number which is less than 0, which means this sign is negative. You want to produce something which is positive. What would you do? Come again? Come again? Comes with a negative. Sorry? I multiply the same number by negative. Negative 1. If I want to produce the same number, I will multiply by negative 1. Is it? So that means now we can say absolute value of x is x when x is non-negative, and it's minus x when if x is already less than 0. Altogether, you will see that this is always going to give you positive for any value of x. Do you notice that? Okay. Now, this is when I'm calculating the absolute value of an individual number. But now if I want to look at an absolute value function, now I need to talk about something which I can say y is equals to f of x equals to absolute value of x, and I also need to see how the graph of that function is going to look like. And we are going to get that exactly from this discussion of got here. Altogether. So let's proceed by, if you have got a question, please ask. Any questions? No. Okay. Then let's get rid of that for now. And get rid of this piece. And check our pen again. That is y. Altogether. Now let's see what this is going to be now. How the graph is going to look like. Remember what I said yesterday. I said the graph of a function is produced from these pairs. You must have x, comma, f of x, isn't it? This is on the graph of the function, isn't it? Okay. So now, if we've got 1 there, 2 there, 3, we'll just imagine that this scale is accurate, but this is a rough sketch, but we need to make sense of what's happening there. Now, if we go on to what we said if we pick 0, let's start at 0. If we pick 0 here, the absolute value of 0 is 0. Why? How many units are there from 0 to 0? 0. So this is going to be 0, 0, x being 0, f of x being 0, isn't it? Then if we go to 1, absolute value of 1, what will be the value? Absolute value of 1? So which means we've got a point there, which is 1, 1. If we go to minus 1, we'll say absolute value of minus 1, and the go according to that formula is minus 1 greater than 0. So we said the absolute value, how we define that thing, we said absolute value of x was x when x is greater or equal to 0, isn't it? It's minus x when x is less than 0. So is x less than 0 here? So we must put minus 1 before minus 1. Minus 1 minus 1? 1. So it's going to be there. So which means that these points are going to be 2, 2, minus 2, 2. Then the graph is going to look like a beautiful what? Capital letter V. Something like that, isn't it? Sorry for that sketch, but I think we'll make sense of what happened, isn't it? So that graph is symmetric. When a graph is like that, we say it's symmetric around Y. Like which graph? Like which graph would you know? Which other graph do you know which is symmetric around Y? The parabola. Altogether, the only problem that the only difference that this one is line straight wings, but the parabola is bending wings. Altogether, that function there is called the absolute value function. What you must need to know, you must need to know how to graph it. You must know its properties. As you can see, from the left, minus infinity to 0 is decreasing, and from 0 onwards is what? Increasing. Altogether. Okay. That is absolute value. Then, same things are going to happen here, like in the parabola. If now I come up with a function like y is equals to absolute value of x minus 1. Absolute value of x minus 1. I can even say absolute value of x minus 1 plus something. What's going to happen? This is a very important thing you must focus with graphs. The graphs, the standard graph, the shape normal does not change. It can be transformed, maybe be narrower or be wider, depending what you do on x. But the shape will not change, isn't it? So this graph, and that graph are exactly the same graph. If you move them, they will sit over each other and you will not identify that they are two graphs altogether. But you must understand what has happened here. When you are in this graph, the line of symmetry here is actually y. Sorry, not y. What? Can you tell me? What is the line of symmetry? What will be the line of symmetry? The y-axis. What is the equation of the y-axis? The equation of the y-axis? X equals to 0. Good. X equals to 0. So that's the thing. Now, but when you come to this one, because there is this kind of shift on the variable, the line of symmetry is going to be shifted to 1. So the line of symmetry here is going to be x equals to 1. Now, there's nothing else to do. What we need to do, let's just pick another ink there and just put a line of symmetry there. And let's make it a bit more complicated by adding 1 here. Let's put 1 there outside the absolute value. What's going to happen now? It means it's going to be lifted up by 1, isn't it? So what's going to happen now? We need to have we're going to have the vertex there. All together. If we're talking about the parabola, the parabola would be a x minus h squared plus k, isn't it? And the h comma k will be the k will be the line of symmetry, isn't it? And the h would be what? H will be the what do you call this? Actually this is a turning point, isn't it? This is a turning point. But as it's being the turning point, K will indicate to us the Y, which is the line of symmetry. And the H will tell us the lowest or the highest X altogether. Then, which means the graph is going to start from there. For this one still plays the role of H. And this one here still plays the role of K, isn't it? So now the graph is going to come here. It's going to more or less like this. Altogether. So it has moved horizontally and vertical. Does that make sense, my sister? Sorry? Come again? But you must talk. You don't need to wait for the doctor to come to you and say, you look sick. Why I asked you actually, your eyes look blank to me. You don't understand this. What I've just drawn now. I'm drawing. Let me raise this thing a bit. I'm drawing the graph of absolute value of x minus 1 plus 1 altogether. But what I've just emphasized, I said, if you've got the absolute value of x minus 1 and the absolute value of x, the graphs, I can maybe abuse the language and say the graphs are basically congruent. You can actually push the other graph over the other. Do you understand what I mean by saying that? My sister, talk to me. Do you understand what I mean, what I'm saying now? Do you understand when I say two triangles are congruent? Okay. Do you understand what I mean by two things exactly of the same size? Like my two hands. If I shift this hand facing down, I can put it on this hand. You cannot see the other hand. You can see it as one hand. Is it? So the black graph and the reddish graph are supposed to be exactly the same graph. But the position changes. What changes the position? Well, that's what I'm saying there. What changes the position is this H, which is a horizontal shift. Now it is shifted horizontal in this direction. It has shifted 1. Are you here, my sister? Then this 1 is like this K, which shows a vertical shift. So it has shifted vertically from 0 here, vertically up to that. So when I'm looking at a graph like this, like when I'm looking at a parabola like this, I must understand that this parabola has shifted horizontal H and the vertical that. So the turning point, instead of being at 0, 0, when I've got this parabola, the turning point is 0, 0. But once I introduce this K and the H here, then the turning point is going to be moved H horizontally and K vertically. Are we together now, my sister? Okay. But please listen to me. When I'm saying something you don't understand, stop me. Don't wait for me to analyze you and see that your eyes look like you don't understand. No, that's not good. Are we together? Yeah, please. So guys, do you understand that? But the most important thing today is not to discuss the parabola or the translations, but if you have problems with that, you can still come and consult, and I can sit down with you and explain those things. Because it's not worth to come to these classes without understanding those things. Please make time, come for consultation. It can be necessary to know where it cuts, especially when you want to sketch it roughly. It's important to determine the turning point and determine where it cuts the x-axis. Because once you determine that, then it will be easy to just draw your graph and you just get a perfect graph. Yeah. So if you want to know where it cuts, then you have got to make your x equal to 0. Isn't it? So now you make your x equal to 0 because the cut on the y-axis, x is always equal to 0. Then after making x equal to 0, you have to calculate your absolute value here. It's going to be, what are going to be left with there? You're going to be left with absolute value of minus 1 plus 1. What is that? It's 2, isn't it? Which means your y is going to be equal to 2. Now you are sitting with the point 0, 2. So which means this point here, if it was accurately drawn, it would be 0, 2. So now once you've got this 0, 2, you draw the line this way. To get the other wing, what do? You just draw, take that distance, transport it on the other side of the mirror line, then you draw exactly the same distance. But now you can see clearly that mine is not the same. Why? It's a rough sketch, isn't it? Yeah, but your imagination must help you to see that thing as a perfect graph which you can understand. Sorry? No, if you say that, then it's a strange question. When something moves on the horizontal, there's no rule which says move only to the absolute value is positive, but the shift cannot always go to on the right, my friend. Because even the parabola, if I put, yeah, maybe this is one of the things I must explain to you. Because what you are telling me now, you are giving me a message. This is the good reason why people should ask questions. When you ask questions, I can actually read in between lines what exactly you don't understand. How to help? Right. Let's now unpack the parabola. As one unpacking the parabola, you must take this thing to the absolute value. You must take this thing to any other function you know. How together? The parabola, I think, is the easiest to illustrate with. I'll show you later on a graph. If I've got a parabola in this form, x minus h. For simplicity, I don't know what other lecturers or teachers say. For simplicity, in my class I always say, my student, read this minus sign. You read that minus sign this way. Say shift by h units. By h units, or shift to h. Altogether. Now, then h there, I don't know whether h is, in this case, I can assume that h is positive. So it's just going to go to the left, isn't it? Then the question comes, what happens now if I've got a parabola given as a x plus h squared plus k, which is exactly the same thing. What do? I would like to reveal my word shift by h units. What did I say? I would like to reveal my word shift by h units. How do I reveal that word in this situation? Who can tell me? Who can tell me? How do I reveal that word in here? Nobody's got the trick. It's not a trick, but it's a fact. What am I going to do? I should remember that at school, I was taught that whenever two minus signs meet each other, this one will kick this one, and they stop like that, and this one jumps over. Then they sleep like that for the rest of their lives. Altogether. Once I've got if I know this combination of signs, then I know that here I've got A brackets X minus H brackets squared plus K. Now my weight shift 2 has come up. Altogether. If I take an H, there's a positive number. Now what happens here? This one will go to the right, positive, isn't it? So it will shift horizontal to the right. Is that right? To the right, to the positive, isn't it? But when I come to the second situation here, I reveal my shift word, then I see that this thing will shift to the left. So this is the same thing which is going to happen with your what? With your plus sign here. If you put a plus sign here, this same graph is going to be shifted to the left. I hope you answered. This kind of situation here, you will take it to any type of a function. It will work exactly as I'm saying. It doesn't matter whether you are dealing with an exponential function, as long as you put minus on the argument there, the graph will shift somehow horizontally. Am I making sense? My sister, are you there? Okay, good. Another question? Another question? Right, I think I'm going to say I've explained this idea of absolute value of a function, and the next thing what you need to do now, you need to go to your notes. Basically, those notes, read them notes, but I see them as a compilation of exercises to do, isn't it? So from the explanation I've done here, try to go in there, do your notes, you look at your notes, and you take examples, work them out. If they're difficult or they're challenging you, bring up the questions, then we discuss them in the tutorial. All together? Okay, so I'll stop there and say thank you for listening.